So I'm going to do now an example where you'll see that even though in principle it is possible to do a double integral using the two different options for the order of integration, in practice sometimes only one of these orders is feasible to use. Okay, so the concrete double integral that I want to work on is the double integral of sine of x over x, where it is being integrated over this triangle. Let's see what happens depending on which order of integration you use. So if you use the order dy dx, again, you want to study this double integral. So you put here dy dx. Put here x, here y. Okay, the problem is on finding the bounds. The bounds are easy. So again, for the order dy dx, you are supposed to use vertical lines. Imagine fixing a value of x. So you fix your favorite value of x, and you are looking at vertical lines that make up this region. Notice that all of them enter, all the pink arrows enter through y equals 0. So that's the lower bound, and they all exit through y equals x. So that's the upper bounds. And again, the upper bound can depend on the remaining variable. And you're varying these pink arrows from 0 to 1. So that's what we have to integrate. And in this case, this gives us, let me just write it again one more time. So this is the same. This is like a constant, so you can, because you're integrating first with respect to y, so you just get the integral from 0 to 1, from 0 of sine of x over x. So you're just like integrating 1, which is gives you y from 0 to x dx. And this is the integral from 0 to 1 of sine of x over x times x minus 0, which is just x, and so that's just the integral from 0 to 1 of sine of x dx. And the integral of sine is negative cosine. And then this is negative cosine of 1, and cosine of 0 is 1, and there's a minus here, so this becomes plus 1. So the integral, this double integral, just gives you 1 minus cosine of 1. And maybe you would like to double check this. So you could try to double check this by using the opposite order of integration. Let me do it here so that you can compare with this other bound. So if you were trying to use the order dx dy, again you would write now xy x equals 1, y equals x, y equals 0. And then you just put the x and y. and you put okay, so for the bounds you're using horizontal arrows. When you fix the value of y, notice that all the lines are entering through this hypotenuse, which has equation x equals y, and they're all exiting through this vertical segment, which has equation x equals 1, and then you're varying these green arrows from 0 to 1. Okay? So that's the double integral you would like to do. So again, this is what we're trying to find. So in practice, in this particular case, the problem is that now we have to integrate this first. But the issue is that we just don't know how to integrate this. But there's really not like a good way to integrate this function. But there is no nice formula for this integral. So essentially we're stuck not because of the bounds, but just because we don't know how to begin the integration process. So in practice, for these kinds of problems, you sort of have to reverse engineer the situation. So what's more typical is that I would have given you like this integral, and I asked you to find this integral. You realize that you cannot find it, right? So you have to know how to visualize what this corresponds to. You realize that it corresponds to this triangle, and then that you can use integration in the opposite order. So this is what we were trying to do, but you realize that you can interchange the roles. You get this, which you can integrate, and the final answer is 1 minus cosine of 1. So this is an example where only one of the two orders works, despite the fact that in principle both would give you the same answer. It's just like we just don't know how to do one of the cases.